to Complexity Made Simple. My name is Paul Allen, and before we get into today's video, just a reminder, some great news: the design of experiments for 21st century engineers, the Minitab version, has just been released. I know for those of you unfortunate enough to have selected Minitab, you have a great deal of difficulty in understanding this software, so we've created this special version of this text with the Minitab screenshots. The link to lulu.com where you can buy this book is in the description below. And of course, you also have the option of purchasing Drink Tea and Read the Paper, which is the perfect book to go with your green belt or Six Sigma black belt training. The link to lulu.com for that book is also in the description below. And of course, the other thing that we'd really love you to do, please go to buymeacoffee.com and make a small donation. All of these things, the purchase of the books and the donations, they help keep the channel moving. I'm really grateful to all of those people who are currently donating. Many thanks for your support and your help. And now let's get on with today's video. Welcome to the latest video, and in this video newsletter we are going to take a look at how Minitab deals with the three probability distributions. So we're going to take a look at Minitab software, and in particular, what's the best way to do probability calcs in Minitab, and in particular the three distributions that you're going to see at work: the binomial, the Poisson, and the normal. Why these three distributions? Because when you collect data, typically you are going to collect one of these three distributions. There are others in your business, but these are the common ones. If I'm honest, this one and this one is the common one. Whenever you look at data and you consider it as pass-fail, you're typically collecting a binomial distribution. Whenever you measure something, like measuring the weight of a Mars bar, you measure the grams, 50 grams, 49 grams, 51 grams, etc. Whenever you measure something, you're going to typically create a normal distribution. The Poisson is a bit more of a special case, but the Poisson is about arrival rate. So if you particularly have lorries per hour arriving at a tipping station for municipal waste, typically lorries per hour is an arrival rate, and you are creating a Poisson distribution. So they are the three common distributions that you tend to see inside most businesses, and therefore we're going to take a look at each one. And the first one we're going to take a look at is the binomial, then we'll look at the Poisson, then finally we'll look at the normal. Let's see how Minitab deals with probability. Okay, now we're going to take a look at how Minitab deals with the Poisson distribution. Now the Poisson distribution in your business is a slightly specialist distribution, but it typically appears when you have an arrival rate. So the little example we're going to set up here is: how many loading bays do you need in order to make sure that you can service the manufacturing process successfully? How many loading bays do you need? Now, why are we picking this? Well, it's because there's an arrival rate. There's a number of lorries going to come up to those loading bays every shift or every hour, etc. And therefore it has an arrival rate. The question is, if I have 5 loading bays, What happens if I get 6 lorries come round the corner? How often would that happen? If I have 7 loading bays, how often would 8 lorries come round the corner? In other words, how often will a queue start to form against my loading bays? So let's take a look at a little scenario and we'll see how things play out with the Poisson distribution. So the first thing we're going to do is just take a look at the problem that we're going to set up here for Minitab to give us the risk, because that's really what probability is telling us. What's the risk of bad things happening? So a company is involved in a Kaizen exercise and they would like to reduce the amount of space being used by the goods inwards department. In order to release the most useful space, however, they must reduce the number of loading bays from 9 that they currently have to 4. If we have 50 deliveries in an 8-hour period, in an 8-hour shift, and it takes 30 minutes to offload each lorry, what's the probability that 4 bays will not be enough? In other words, we get 5 lorries come round the corner. Now these loading bays support a just-in-time manufacturing situation. There is literally only 30 minutes worth of stock sitting against each production line. If we don't keep a constant flow of offload deliveries moving into the factory, there is a chance we will stop the production lines. So these are very important loading bays. So that's the scenario, and now what we have to do is to go to Minitab for the answers. So once again we're going to go graph, we're going to go probability distribution, and we're going to go view probability as before. Now this time, look, we've got to drop the menu. This time we've got to select Poisson. And now look, it asks me for an average. So that's the only parameter that this distribution needs. So before we go any further, we're going to have to work out an average arrival rate for these lorries. Let's do that first. Okay, let's just remind ourselves of the problem. We've got 50 arrivals in 8 hours, and we have a 30-minute offload time. And it's this window that's going to cause us a problem, because when the first lorry arrives, we're going to spend 30 minutes offloading that lorry. What we're scared of is too many lorries come before that 30 minutes is up, and we start to form queues at the loading bays. Okay, so the arrival rate must be set in a 30-minute window. So let's have a look. If I divide 50 by 8, what do I get? 6.25 lorries per hour, but we want it for 30 minutes. If I cut that in half, I end up with 3.125 lorries per 30 minutes. So that's the average arrival rate, 3 and a bit lorries per 30 minutes. That's the average. But what we want to know is, I know it's the average, but when you get extremes, when you get variability, could I get 6 lorries arrive, 8 lorries arrive? What's the probability? All right. So there's our parameter, our arrival rate. Now we can ask Minitab the right question. So let's put 3.125 in there. We've worked that out. Go to the shaded area again. And again, what are we interested in? Well, we're interested in the right-hand tail. And the value that scares us is, of course, 5. So what this calculation is going to do is to say, what's the probability of 5 or more lorries coming round the corner in any 30-minute window? So if I click OK to that now, just pop that out. What do we get? Look, we get 0.206, 20.6% chance. So let's put that on the board, 20.6. So what we're saying is there is a 20.6% chance we will overload these loading bays. So another way to look at it maybe is once a week we could stop the production lines. Once a week. That's a serious problem right there. Now remember the problem. They currently have 9 loading bays. So how about if I put 10 into that calculation? What's the probability currently of overloading the 9 loading bays? Let's take a look at that. So again, we go up to Graph, Probability Distribution, View Probability. Click OK. The arrival rate is the same, but of course when we go to the shaded area now, the value we're interested in is 10. What's the probability of getting 10 or more lorries if we maintained 9 loading bays? Let's take a look at that. Just pop that out. What do we get? Well, look, that's a tiny little figure. That's 0.1%. Let's put that on the board. So currently the chance of overloading the bays is just 0.1%, and we're about to wind that up to 20%. But look at this arrival rate. It would be very easy. You have 4 bays. You only have an average of 3 lorries every 30 minutes arriving. It sounds like you've got a bay too many. It would be very easy to make a gut reaction here and think that this system will work perfectly well. Again, that is probability, playing with your day, playing with your decision making inside your company. Understand these distributions and make sure that you're in control of probability, not probability in control of you.